Welcome everyone. Now, just to recall the last lecture in which we have seen the addresses that if you consider a data communication between two pieces, okay, or the data communication between two systems, then you require different types of addresses. And which are those addresses? Yeah, at data link layer and physical or lower layers, normally you use MAC address. It is also known as hardware address. It is also known as physical address. If you go for network layer, then it is logical address. Then it is known as IP address, IP version 4, IP version 6, or in IP you will find class A, class B, class C, class D, and class C. And every class, that is class A, private public, class B, private public, class C, private public. So such type of addressing is used at a network layer. And whenever you go for transport layer, okay, at a transport layer, normally port addresses are used. And port addresses, we have seen FTP uses TCP port number 21, then telnet uses 23, DNS uses 53, HTTP uses port 80, and SMTP uses port number 25. Such type of different applications, they are using different types of transport layer port addresses. And finally, at application layer, a user specific addresses like rcjaiswal at pict.edu, jaiswalrc at gmail.com, jaiswalrc at yahoo.com. So such type of users which are working at the application layer of TCP/IP protocol stack, they are normally defined. Now, why these different addresses are required, that one by one we will see. So before that, I would like to explain you the example between two systems. This is the system 1, this is the system 2. This is the sending system, this is the receiving system, and they want to communicate with each other. So for networking, the basic fundamental thing is a data communication. Why networking is required? Networking is required for data communication. So very simple example I have given over here. So let us say application layer, presentation, session, transport, network, data link layer, physical layer. Then physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So if you see the direction of arrows, okay, let us say sending node. If it want to communicate with this, let us say at a receiver and you have a Google web server. So Google web server is going to receive the different queries for which the different web pages and related information is asked. And this is nothing but the browser which is running on this specific sending device or any machine or any client. So always a communication is between a client and a server, or a sending or receiver, and a vice versa. Please keep this in your mind. So let us say this machine is equipped with the different types of browsers like Internet Explorer, Google Chrome, Firefox, Opera, Apple Safari, and so on. Okay, such type of browsers are there. So you just go to that browser and type http colon double slash google.com. So let us say the moment you go and enter http colon double slash google.com, the data is coming from application layer to presentation to session to transport to network to data link to physical. And on physical layer, it may be a wired or wireless link. It is communicating with this physical layer, and from this physical layer, data link, network, transport, session, presentation, application, and then it communicates with this Google web server. And Google web server, what is there on Google web server? A Google web page. That web page is taken, and again a reverse journey is followed, and that web page is coming to the application layer of this requesting device, that is nothing but in a browser. Please keep this in your mind. So such type of journey is there. Please keep this in your mind. At application layer, you are requesting for web page. The data is coming like this, going to web server. The data is fetched, that is web page is fetched and given to the requesting device, that is browser. Now next, so the process in a computer networks, let us say these two machines are there. So let us say this machine, it is there in a PICT, and this is a google.com web server which is there in the USA. And this machine want to communicate with this machine which is there in the USA. So please keep this in your mind. So this is, let us say, a DSP lab where your ITCCN practicals are being conducted, or any laboratory where the practicals are being conducted. Okay, from that to a layer 2 switch, from to a PICT router, then from PICT router to USA. N number of countries are there. Depending upon the network condition, it will find, this router will find the shortest and the fastest path through different countries, through different service providers. Please keep this in your mind. So let us say a PICT, let us say we are using Reliance as a service provider. From Reliance to, let us say, another country, China. From this China to, let us say, Europe. From Europe to Canada. From Canada to US, and directly the google.com web server, which is there in New York. And from this New York, again that web page will come to Canada router, then a Europe router, then a China router, then a Reliance router, and finally comes to your client. So such type of journey of packet is there. Please keep this in your mind. So why do we need different addresses? So just keep this in your mind. So we are using browser on this host, and let us say a web server is hosted on this machine. So the moment you take this machine and install a web server, port number 80 is going to be opened at a transport layer of this web server. Okay, so the moment it communicates with this, it goes to the port 80, take that web page, comes back through this uh, road journey, and finally the web page is coming to the browser, and you observe that web page. Second thing, okay, now on the same Google web server, if you install a FTP server and you want to transfer a file, let us say it may be a movie file, or it may be a database file, or a number of files are there, so you will have to install a FTP server. So FTP server and application is completely different from this web server and its application. Okay, so FTP server is different. So whenever you install FTP server, the moment you install FTP server, port number 21 is going to be opened at a transport layer of that server or this machine. So port number 21 is used for FTP. So let us say my machine want to communicate with the FTP server which is installed on the same machine. Please keep this in your mind. On the same machine, if you install web server, port number 80 of transport layer is being used. On the same machine, if you install FTP server, port number 21 will be used. On the same machine, if you install a telnet server, remotely I want to configure and control this machine, then I will have to install this telnet server. So multiple servers can be installed on one physical machine. That is the main concept. If you understand this, then you will understand why these different addresses are required. Please keep this in your mind. The client machine, with the help of browser, it is communicating with a web page using port 80. A client machine using a browser is communicating to FTP server through port number 21. And a client machine want to control this remote machine, then you require a telnet utility, and for which transport layer port number 23 is used. So please keep this in your mind that for web page hosting, port 80. So another section is used. Port number 21 for FTP, a different section is there. And telnet, that is remote execution, a different application and different section is there. So for different processes itself, the port addresses required are different. So this is the need. Please keep this in your mind that web server provides web pages, FTP server provides files, and telnet server provides remote execution. The processes or the application itself, they are different. Please keep this in your mind. That's why port addresses are different. So please keep this in your mind that other than this, as port addresses are different at different level or different layer, we have already seen that different addresses are there. That is MAC address, IP address, then port address, and finally user specific address. Okay. So now, why different types of addresses are required? It is very important slide which I have taken from Farozan's book. Farozan is the Bible for data communication and networking. whether you are going for a coding, or if you really want to understand the computer network practically, then you have to go for this Forozon's book. So now the first point is the data link layer is responsible for delivery of frames between two neighboring nodes over a link. This is called as node to node delivery. Number two, the network layer is responsible for delivery of datagrams between two hosts. This is called as host to host delivery. Number three, communication on the internet is not defined as the exchange of data between two nodes or between two hosts. Real communication takes place between two processes or application programs. We need process to process delivery. Please keep this in your mind. So another sentence says that the transport layer is responsible for process to process delivery. So two process communicates in client server relationship. Okay, after the execution of application or application layer, process start at a transport layer through port addresses and terminates at a transport layer of another server through TCP UDP port addresses depending upon application. So please keep this in your mind. So in previous slide what we have seen this thing, that let us say two switches or two routers. So MAC address is more than sufficient for their communication. So if you are talking about two switches, layer two switches, let us say DSP lab switch and VLSI lab switch. If you want a communication between two, then MAC address or MAC table, both the switches maintains. So they just check that MAC entry, media access control, or physical address or hardware address entry in that a switching table, and they communicate faster. Whenever you are talking about PC to PC communication, then you require, or host to host communication, then you require IP address. But let us say on one host, if different servers are running, okay, if different servers are running, which uses different port addresses, port 80, port 21, and port 23, then this type of applications are known as processes. So web processing, FTP processing, telnet processing. So process to process delivery, web browsing, process to process delivery, file transferring, process to process delivery, remote execution, process to process delivery, and hence it is known as different types of addresses are required for such type of communication. Okay. So now let us start with the MAC address. MAC address is nothing but 48-bit serial number, in which first 24-bit it is a vendor code and remaining 24-bit is nothing but a serial number. So total 48-bit. Okay. So as I told you, vendor, the different manufacturer of the LAN card. So basically this MAC address is burned into the ROM of LAN card or network interface card. Please keep this in your mind. Okay, the MAC address is burned into the ROM of LAN card. It is also known as network interface card. Okay, next. See this. As I told you, a vendor code. See in previous slide, first 24-bit as a vendor code and remaining 24-bit is nothing but a serial number. So let us start with these different vendors. Which are those vendors? Which manufactures the different LAN cards or network interface card, and accordingly those vendor codes are burned into the ROM of their LAN card. So the different vendors, they are like Cisco, Intel, Tektronix, AT&T, Epson, HP, Hitachi, Novell, IBM, Wipro, Nokia, Realtek. See this. 5 years before, we were using D-Link cards in every PC of every laboratory. So if you go and find out the MAC address, you will find out 0050BA, initial 24-bit, and remaining 24-bit serial number will be different. So MAC addresses uniquely identify each node in a network at a media access control layer, the part of a link layer. So now all of you try to understand. A data link layer is divided in two parts. Number one, LLC, and number two, MAC. The upper portion is logic link control, and the lower portion of data link layer is nothing but a media access control. Please keep this in your mind. The one that directly interfaces with the media, such as the actual wires in the twisted pair Ethernet. In modern Ethernet, the MAC address consists of 6 bytes or 48 bits, which are usually displayed in hexadecimal format. So now there are two processes, two ways to understand that. Let us say your laptop. What is the MAC address and which vendor has designed and manufactured the LAN card of your laptop? How to know? Number one, if you open the laptop and see the LAN card in that, on the back side, they have written with the paint, or sometimes they use a sticker where this type of MAC address is pasted. Okay, and second way, without opening laptop, how to know the MAC address of any machine? Go to command prompt and just type ipconfig/all. If it is a Windows operating system, go to command prompt and type ipconfig/all. Immediately you will get the MAC address of the LAN card which is being used for your LAN as well as internet communication. And if you are using a Linux operating system, so instead of ipconfig/all, you use ifconfig/all. So with the help of these commands at a command prompt, you can immediately come to know what is the MAC address of your LAN card of your laptop or machine. Next, IP address at a network layer. So as I told you, IP address, they are defined. IP address is classified in two types. Number one, IP version 4, IP version 6. If it is IP version 4, class A, class B, class C, class D, class C. Class A, private public. Class B, private public. Class C, private public. Class D is used for multicasting. Just try to recall the previous lecture. I told you there are three types of bandwidth consumers: unicast, broadcast, and multicast. Unicast 1 to 1, broadcast 1 to all, and multicast 1 to a group of specific computers. So this is multicasting. Class D is reserved for multicasting type of application, and class E is reserved for future use. So IP version 4 and IP version 6, these are the basic classification of IP address, which is a part of logical address or which is a part of network layer address. It is IP version 4, IP version 6. Next, in IP version 4, A, B, C, D, E, and in every class you will find class A private, public, and private, public. Next, what is the IP address? IP address is basically 32 bits. So 4 octets are there. So you might have heard 10.10.10.5, 192.168.3.1. So such type of addresses is nothing but IP addresses. Now, as I told you, see this class A, class B, class C. D is for multicasting and E is reserved for future use. So we will see class A, class B, and class C type of IP address, how they are denoted. Let us say class A. In class A, as I told you, IP version 4 is nothing but 32-bit IP address is there. 32-bit, 4 octets. So let us say in class A, let us say 4 octets are there. First, second, third, fourth. Class B, first, second, third, fourth. Class C, first octet, second octet, third octet, and fourth octet. So in class A, the first octet is known as network ID, and remaining 3 octets, they are known as host ID. In class B, first 2 octets, they are known as network ID, and remaining 2 octets are known as host ID. And in class C, first 3 octets, they are known as network ID, whereas fourth octet is known as host ID. So what is this network ID and host ID? Very simple definition. A network ID identifies a physical network. All hosts, okay, all hosts on the same network require same network ID, which should be unique to internetwork. What is the meaning? So in PICT campus, entire campus, we are using class A IP address. The DHCP server, which is installed as an authentication server in a server room, okay, it uses class A IP address allocation, dynamically allocation of IP address to every machine who is requesting for internet is a class A. So in which the first octet is known as network ID and remaining 3 octets, they are known as host ID. Please keep this in your mind. Then class B, 2 octets as a network ID and remaining 2 octets as a host ID. And class C, first 3 octets, they are known as host ID, whereas the fourth octet is known as host ID. These first 3 octets is a network ID and remaining fourth octet is a host ID. Next. Now, this slide is very important. As I told you, in IP version flow, in IP version 4, there are 5 classes: A, B, C, D, and E. D is reserved for multicasting. And okay, D is used for multicasting type of application, and E is reserved for future use. So now all of you give attention. If it is a class A IP address, then the IP address range is given by 1.0.0.0 to 1.255.255.255. 2 in this first octet is changing from 1 to 126. So it may be 1, 2, 3, 4, 5, 6, 7, 8, 90, 91, 90, 200, 120, 124, 5, and 126. So if the first octet value is changing from 1 to 126, and accordingly the remaining numbers, such type of network is known as class A network or class A IP address network. Next, after 126, class B directly starts from 128. So 128.0.0.0 to 128.255.255.255. So this 128 is changing from 128 to 191. That is, the meaning is 128, 129, 130, 150, 190, and 191. So it is called as class B. So, and finally, C, 192.0.0 to 192.255.255.255, and this 192 is changing from 192 to 223. Okay, so 192, 193, 194, 190, 200, 220, 221, and up to 223, and accordingly those numbers called as class C. And here 224 to 239 class D, to 224.255.255.255, and finally class E 240. Okay, up to 239 it is class D, and class E 240 to 247. Please keep this in your mind. Dot 0.0 to 240 dot 255 dot 255 dot 255. So class A network, if you see, this is called as network ID and this is called as host ID. So host ID is maximum, and hence maximum number of hosts can be connected. So it is known as very large network. So for very large network, normally such class A IP addresses are normally used. Okay, to our PICT campus, the number of machines are, they are not more than 4,000, but still we are using. What is the capacity of class A IP version 4 addressing? 255 into 255 into 255 millions of IP addresses and machines can be connected with the help of given class, that is class A. Class B, medium network, because network ID is this and this. So 255 into 255, those many hosts or application host can be connected with the help of this class B IP address. And finally class C, 1, 2, 3. These 3 octets, they are a part of network ID and host ID. That is only 1 octet. So only 255 machines can be connected in 1 network. Please keep this in your mind. So this is about IP version 4, class A, class B, class C, class D, class C. Now, after 126, you will find one number is missing, that is 127. See, after 191, it is 192. After 223, it is 224. But here, after 126, it is 128. So where is this 127? This 127 dot 0 dot 1, 127 dot 0 dot 0 dot 1 is a local loopback address, or this loopback address, or test loopback address. It is used to identify network interface card connectivity in your PC. In routers, it is used to identify the remote interface from your router. So if you really want to ping, you might have used a ping command whenever you are dealing with any PC in your laboratory. So whenever you use ping IP address, it sends 4 packets of 32 byte each from one PC to another PC and echo back that packets. But here, if self machine pinging you have to do, then you have to use 127.0.0.1 indicates loopback address, that pinging to self machine with the help of this IP address. So please keep this in your mind. In ITCCN oral exam, examiner may ask you what is loopback address and what is that range. So you please keep this in your mind that it is 127.0.0.1. Next, as I told you, every IP address is okay. Just try to recall this slide. IP version 4. A, B, C, D, E. D is for multicasting and E is reserved for future use. See this class A, class B and class C. In every class you will find private, public. Class B, private, public. Class C, private, public. The same thing I'm telling you over here. Okay, this is class A, private. This is class B, private, and class C, private. Please keep this in your mind. Other than this, whatever IP addresses which are available in this entire range is known as public IP address. So public IP address, you have to pay the money to service provider to get that public IP address. But whereas this private IP address, see this, international, or it is international authority basically. The Internet Assigned Number Authority, IANA, it is an international authority, has reserved the following 3 blocks of IP address space for private internets. Please keep this in your mind. So let us say it is 10.0.0.0 to 10.255.255.255. It is called as Class A address, private IP address range. This is Class B private IP address range. This is Class C private IP address range. So in Class A, okay, almost 1 crore 67 lakh 77,216 machines can be connected. If you go for Class B, 10,48,576 machines can be connected. And if you go for Class C, 65,536 machines can be connected. Please keep this in your mind. What is the meaning of this private address space? You go to any college, you go to CUAP, you go to IIT, you go to any NIT, you go to Cummins College, you go to MIT College, you go to PVG College, you go to VIT College, you go to any college, you go to any IT industries, you go to Infosys, you go to Calsoft. Anywhere you go, you will find the IP address used by their employee will be in this range only. Please keep this in your mind. This is the private IP addresses. So in PICT, we are using Class A. So whenever your mobile, whenever your laptop is connected to PICT server room through authentication server, that authentication server always allocates you this private IP address, private Class A IP address. Have you understood this? So this is what a private IP address. Okay. Now, as I told you in previous slide, that IP address is divided into 2 parts: Class A, Class B, Class C. That Class A is divided in 2 parts: private and public. Class B, private, public. Class C, private, public. So these are the private IP addresses which are free of cost. That INA authority has already declared in the documentation that these IP address can be used at free of cost in any campuses. Please keep this in your mind. Likewise, if you see the TCP IP configuration practically, for every IP address, there is a default subnet mask. If it is a class A IP address, if you enter, default subnet mask is 255.0.0.0 without subnetting. If you enter class B IP address, automatically it gives you 255.255.0.0. And if you enter class C IP address manually, or it may be dynamically, then by default the subnet mask is 255.255.255.0. These are the numbers when the subnetting is not done in your campus. Please keep this in your mind. If the subnetting is done, this number would have been different. Please keep this in your mind. And what is this subnetting? Now, right now, you just keep in your mind that subnetting is necessary to reduce the local broadcast and to avoid the network congestion and to increase the security. So these are the two main advantage of this subnetting. So subnetting is a different concept that will be taught to you in a computer network subject uh, in next semester, that is in B. Okay, next, one more thing I told you, that a logical address or a network layer address, okay, it is divided into two parts, or it is classified as IP version 4, IP version 6. IP version 4, we have taken this thing in detail, is a 32-bit bit in which 4 octets are there, and accordingly every octet is represented by a binary number. Okay, so this octet represented in decimals, that is what IPv4 32-bit number is there. So 2 raised to 32, 4 billions. So 4 billion IP addresses are possible. If you go for, then what is the need of IPv6? IPv6 is known as next generation, IP next generation IP address. So why this IPv6 is needed? Please keep this in your mind. IP version 4, 2 raised to 32, 4. That is 4 billion IP address. So if you consider a one IP address is given to every person on the earth population, according to Wikipedia survey last year, it was around 7 billion. So if you give one IP address to every person, 3 billion IP addresses are lacking. We don't have sufficient number of IP addresses. So if you really want to give one IP address to every person, then IP version 4, this IPv4 IP address are, we are lacking those IP address. Then what is the solution? That is IPv6. So instead of 32-bit number, it will be a 128-bit number. So 2 raised to 128, those many IP addresses will be possible in IP version 6. So millions of IP addresses can be given to each person. Here you are not getting one IP address per person, but here millions of IP addresses can be given to each person, because it is a 128-bit, 2 raised to 128, billions IP addresses are available. Okay, in 128 bits, if you understand this, then basically there are 16 octets, as we represent IP version 4 by 32-bit, that is 4 octets are there. Likewise, IPv6 is represented by 120 bit 128 bit number, and basically 16 such octets are used as far as this IPv6 is concerned. So what are the advantages of IPv6? And the first advantage, immediately you have understood that a number of IP addresses are more, and n number of IP addresses can be given to a single person, and so on. So there is no problem of number of IP addresses. Again, the flaws which were there in IP version 4, okay, they are removed and they are minimized to a certain extent. Then built-in security is there. So all these further advantages which are included in IP version 6, which you are going to study in next year, that is computer networks and security subjects. So now, as far as today's lecture is concerned, now today we will stop here, and our next lecture we are going to see how exactly the ISO-SR reference model works, and what is the role of TCP/IP protocol stack, the details of different protocols in next lecture. Okay, thank you very much for listening this session with patience. Thank you.